Hello and welcome to TelecomTV's Two Pint Problem. We're here in Baker Street, land of Sherlock Holmes, and I have with me my two normal colleagues who are with me on these occasions. Ian Scales on my right, who's the managing editor of TelecomTV, and Martyn Taylor, who is the CTO of Metaswitch. Welcome both, good to see you again. We're going to move on a bit today, and I'd like to begin with a fairly lengthy sort of little intro for this, so if you bear with me, but I think it's pertinent. It's about Wi-Fi and what happens to Wi-Fi. So there are quite a few FON and FON phone style networks dotted about the place these days, and there's another one just being put together in Australia. However, the truth is that the idea's been around for quite a while now, and it doesn't seem to be taking off to the extent that I at least thought it might have done. For example, BT has been talking about this for a long time, and it's one of the most experienced Wi-Fi telcos out there, but it's being very quiet about this development. We're not hearing much about it, so that naturally, being a journalist, makes me suspicious to start with. But we're seeing telcos and cable cos from all over the shop now leaping into the phone dual SSID game, and then this is really hot off the press. This has only happened in the past couple of days. Google's getting in on the act, of course, as it would. Driverless cars, why not phone and SSID, dual SSID and so on. And they're talking about coming up with a cloud Wi-Fi global network. So what does it mean?
Well, I think it's worth remembering that Wi-Fi spectrum is unlicensed and therefore free.
Yeah.
Of course, it has very short range, but if you've got a massive number of hotspots, then in effect you can become effectively a mobile operator without ever having to make a multi-billion-dollar investment in licensing spectrum. So I just see it as a stealthy way for network operators who want to play in mobile services to roll out a network that eventually becomes essentially ubiquitous. Maybe not while you're driving, long distances on the freeway or the motorway or whatever, but and who knows, of course. I mean, the possible ways of extending Wi-Fi into the car, even, but obviously
like Google's there
over LTE.
Yeah.
But for a fixed network operator, maybe building a mobile network that's based largely on Wi-Fi, but maybe with LTE in some other areas, or maybe some roaming arrangements, but where the vast majority of data and voice and video minutes are on their own Wi-Fi network. I mean, that seems like a very interesting alternative strategy to the kind of traditional mobile network operator.
Yeah, it does.
Ian, you're well versed in this.
Well, the thing is, I've been sort of wondering about when it was going to take off. I mean, we've been writing about it for so many years now. Always seem to be poised to. But very recently, we've had a sort of spate of Wi-Fi announcements, really. As you say, Martyn, there was the Google thing over the weekend, which is very, very interesting. And in fact, they're kind of characterising it as cloud Wi-Fi, which I wonder why nobody's thought of that before. Because actually, in its conception, Wi-Fi is a kind of cloud one. It'll scale brilliantly. You can have loads and loads of different Wi-Fi endpoints, a bit of broadband into the cloud, and then a controller somewhere. And you could have a global Wi-Fi network, couldn't you? You could have millions and millions of endpoints. So the other great thing about it is that it scales in a way that Google would really like, and it would work. And it means that other people make the investment in their amenity Wi-Fi, and Google will get all the information and the ability to put ads on it.
Yeah, exactly.
So it's a perfect for that point of view. But I wonder too, a lot of big companies are getting in on it. Like for instance, Comcast is doing, I think it's 8 million FON style installations. So users that are going to have these dual identity Wi-Fi stations, and they are the neighbours to use it as well, or people wandering around on the streets. It's to turn part of your capacity into essentially a cellular network. And that's just built up over the past few weeks, or past few months. And it seems to me like it's the place to go now. If you're a fixed infrastructure provider, you want to be able to get wireless endpoints out there. And
mobility is everything.
Put your stake in the ground.
So rather than trying to duke it out to buy licensed spectrum,
yes,
in an auction, you just build out ubiquitous Wi-Fi instead. I mean, we're seeing some interesting plays around hosted business voice, where there's always a strong mobility element, where if you've got ubiquitous Wi-Fi, and of course everyone has Wi-Fi in their homes and offices, then your business phone extension, which is typically an app on a smartphone, is pretty well always reachable.
Yes,
and
exactly.
you may have to have some fallback where the call gets diverted over the cellular network, but 95% of the time that isn't necessary. So you get to carry those calls on your own network and you get all the rich features of the hosted business service with it.
And again, we've made this point before, haven't we? But it's often the very simple thing which can scale up to become the very complex thing. And the Wi-Fi is going to be a little bit like that, a bit like we were talking about Ethernet, kind of has done that over the centuries. Wi-Fi is a little bit like that in that you're now going to have quite sophisticated sort of applications running off because it's so simple. It doesn't have a lot of complexity in the middle mile. It's just an access mechanism into the internet, and then you can have your servers anywhere. So it kind of suits the moment as well, doesn't it?
Yeah. I know there's been a lot of back and forth on this whole question of the mobile operator, the traditional mobile
Yes.
operators, leveraging Wi-Fi as kind of offload, and then it's all about you need clever software in the handset to make a decision whether to use the Wi-Fi network or the cellular network. I mean, I'm not sure that's really worth a candle. I mean, at the end of the day, if there's Wi-Fi there, you've got a subscription to use that service, and the app is smart enough to make use of that. When it's available, it's kind of like an over-the-top play, of course. But,
Yes.
But it works.
Yes, it's good enough, as they say always, and good enough always wins out in the end, doesn't it?
We're chomping through time, and we've got to get on to the next question.
Okay.
So let's do it. And this is, Martyn, one really for you. You know more about this, and certainly more about it than I do. And I know about Ian. What networking challenges persist in hyperscale data centres, and why should telcos be vigilant about it? At the recent SDN World Congress in Paris, Microsoft presented their strategy to move away from Layer 2 based virtual network to an exclusively Layer 3 approach based on BGP, Border Gateway Protocol, and we believe similar moves have taken place with Amazon and Google. Why? What's going on?
Well, telcos, particularly those looking at NFV, are probably expecting to use one of the existing cloud software solutions, like OpenStack, which is the best known open source cloud software solution. And but maybe overlooking the fact that OpenStack was designed almost to emulate the Amazon cloud, if you like. And the Amazon cloud is all about hosting thousands of individual tenants, each of whom need their own little private network. If you're in an NFV environment, you may have thousands and thousands of virtual machines all doing network work, but all essentially within the same network operator's network. So the question is a solution that's been engineered to support many hundreds or thousands of individual little tenant networks. Does that map to an NFV situation where you've got a massive data center where everything is under the control of one network operator? And our view is that solutions like OpenStack have they've addressed a particular problem with a solution that is inefficient and complex when you compare it with the needs of a massive data center that's just running one set of stuff within one operator's network. They're running these overlay networks where essentially you're encapsulating Ethernet packets over an IP underlay network. So you've got a kind of nested protocol stack. That creates inefficiency, it adds to the problems of management and troubleshooting. It means it's harder to apply policy-based controls in the infrastructure network. And our view certainly is that flattening those protocol layers and just running everything over a Layer 3 network infrastructure is the right way to go for NFV and for very large-scale data centers where it's all under the control of one organization. So as I say, we've seen it happening amongst some of the very big operators of hyperscale data centers, and we think that telcos need to adopt that approach for NFV because it's just a better fit for that kind of application than this unnecessarily complicated underlay style networking.
Right. And what are the signs now? Are most of them adopting the underlay-overlay approach at the moment?
That's the default. I mean,
Yes.
If you take OpenStack, any of the OpenStack distributions, they either let you use VLANs which don't scale very well, or they let you use the overlay-underlay approach, which itself has got some issues of scalability, but also, as I say, complexity and efficiency.
Right.
Now, we did some work recently in the ETSI NFV working group to get written into the specifications for the infrastructure networking for NFV this idea of a flat Layer 3 network. So the option is now there, at least in the draft versions of the standard. Standard's yet to be published, but at least now it's there in black and white, if you like. We've got some work going on now also to actually implement an open source implementation of that approach, so that it becomes something that people can start playing with and start seeing the benefits of.
So what's your feeling about that? Have you got the wind behind you on that?
Well, I mean, we've talked to many of the players in the OpenStack community about it, and I mean the reaction's been uniformly positive. That's a great idea. That really simplifies things. That solves an awful lot of other issues. And they, it's amazing. They keep coming up with, oh, that solves the multicast issue, and that makes it, that solves this particular high availability issue that we've been having with this approach.
Yeah.
So.
Light bulbs are going off.
A little bit, yeah. And it's kind of going back to basics and saying, let's strip away layers of complexity that just simply don't apply in this environment.
I assume it's all IP version 6 by now in these data sets.
Well, version 4 or version 6. I mean, the technique works in both situations, and whether it's 4 or 6 just depends on the policy of that network operator.
Oh, okay. And so there's still quite a bit of IP4. I'm thinking about in the big data centers.
Mm-hmm. Oh, yeah.
Really?
Yeah.
Oh, right. Okay. Well, I suppose you can
private IP address spaces.
Yes, exactly. Yeah. Maybe that's got some advantages in a way.
Well, I mean, remember, some networking equipment is still catching up with IP version 6. They implement the IP version 4 in hardware and IP version 6 in software. Some of them. Now, that's changing, but IP version 6 still can be a performance challenge for certain pieces of network equipment.
One of the slowest introductions I've ever seen.
Well,
I'm sure it was 20 years ago I was writing about the arrival of IP version 6.
It's quite disruptive, and so people have pushed back on it until the moment it becomes absolutely necessary. But we have seen some innovative uses of it. I mean, Deutsche Telekom have made some very innovative use of IP version 6 in their TerraStream rollout in Central Europe. So it's definitely coming, and it does create some interesting new possibilities. Again, flattening and simplifying the network, taking advantage of the enormous address space that IPv6 offers you, creates some interesting new possibilities.
So you don't have to go segmenting everything up with network address translation.
Exactly.
Everywhere.
Yeah.
Yeah. Okay.
Well done, chaps. So you knew more about that than I did, to say the least of it. Very entertaining. Martyn, Ian, thanks again as usual. Thanks for being here, and it's goodbye from us here in the Allsop Arms in close by Baker Street. And until the next time, good health. Cheers, chaps.
Cheers.